Okay, so for the sleep data, if we think about doing this for the sleep data, we're not going to pretend that the true standard deviation is 2.5 or not. I just totally made that up. I don't know what the standard deviation of the hours slept by every single student at UNSW is, so I don't know that sigma is 2.5. But I do have a sample of 185 people. So I do know that this statistic here has a T184 distribution. And MATLAB tells me that for a T184 distribution, (95% of the time I'm within 1.97 estimated standard errors. 1.973 actually, of the true mean. So the way I did that, as before, I said if I want 95% in the middle, I want 2.5% in each tail. So the area to the left is 97.5%. So I went T-inv 0.975, comma, 184 to get my answer. All right, so if 95% of the time I'm within 1.973 estimated standard errors of the true mean, then a 95% confidence interval for the true mean hours slept by all students, all of them, okay? Oh, and now I'm going to need the standard deviation as well. That ends up being 2.497. So that's where I got the, that's actually where I got the 2.5 from. I said, well, that's about 2.5, so I'll just pretend it is. Then we just crunch the numbers. So our margin of error is about 0.36. So our confidence interval goes from about 5.76 up to 6.48. It's very similar to what we had before, isn't it? It's very similar because we had a big sample size. So replacing Z with T didn't make much difference. Remember back on this, this picture here, if your sample size is big enough, if the degrees of freedom is big enough, the T distribution's a lot like the standard normal. Hence, our critical value was a lot like what you have for the standard normal, it was a lot like 1.96. If we had a small sample size, if we had like 10 people, it'd be a different story. Okay, for 10 people, my degrees of freedom would have been 9, and I would have got 2.26. I would have got something that was much bigger. Okay, so for a small sample size, T distribution matters. For a big sample size, it's not such a big deal.